processor. So processor is the main component of embedded system. So the main part of the embedded system is processor. In our previous class, we discussed about the different operation bit of the processor, that is 8-bit processor, 16-bit processor, 32-bit processor and 64-bit processor, like that. Even DSP processor. So the main part of the embedded system is processor, and actually it is known by the name embedded processor. So for embedded system designer, actually this processor processing knowledge is coming from the microprocessor.
Hello, sir. Hello, sir.
Okay, so embedded system, the basic part of the embedded system is microprocessor, and the knowledge of the microprocessor is important because the basic programming style which we are follow, that is the step by step execution of the program, is coming from the microprocessor. So there are two parts of any processor. First is the fetch and second is execution. Fetch means it select the instructions and based on the instruction or according to the instruction it complete the task. So these are the main two operations of any processor, fetch and execute. And there are two essential units. One is control unit and other is execution unit. The function of control unit to provide the connection, interconnection between its input, output and the interface, accumulators, registers, etc. in a planful manner. So you can say that the control unit is one of the main part. This name control unit suggests that it works such a way that the other operations are performed smoothly and well organized manner. So the two essential part, one part is control unit and the other part is the execution unit. When you comment that display 47H in the port B, this part is taken care by the execution unit, and the operations I already discussed. The fetch, the 47, that is the number which is stored in the register and it goes to the accumulator or it acquired from any other sources and it is in the accumulators, and then as per the instructions it execute. So there are various type of processor. General purpose processor, which is used to perform the general operations like the microprocessor, microcontroller, embedded processor, digital signal processor. Now we may ask that what is the difference between the microcontroller and the embedded processor? So I say that the processor is the heart. Microcontroller is used for some specific applications, specific design, and not for specific design. It is for general purpose. But when you design a processor in using the VLSI circuits or any others, that type of processor will be called the embedded processor. The microcontroller you can use to develop the embedded system, but application specific system processor, which are ASSP, these are the dedicated processor and it's designed to serve that purpose only. That's called the application system specific system processor, that is ASSP. Like the ASIC, application specific uh, design, is also there. And another type of processor is multi-processor system, and these multi-processor systems are designed the combination of different general purpose processor. When the task is multiple tasks is required to execute, a single processor not able to execute a task simultaneously, because the microprocessor or microcontroller, which you say that they are execute the operation line by line, means instruction by instructions, means one single instruction at a time. So it's clear that one single instructions is executed in single time, but in some operations multiple tasks is required to execute at the same time, means without any time gap. Then we think about the multi-processor system. Another aspect is that when your task is complicated and it requires to division of your task, that is the task, a bigger task is chopped into a several part and it execute at a parallel manner, so that the processing time is less. In that case we consider multi-processor system. So processors are differentiated as general purpose processor, application specific system processor, and the multi-processor system, which are designed using general purpose processor. So all of you know about the microprocessor in your BTech course. So I just repeat. Nowadays in different uh, meeting of syllabus committee of different university, I always say that the microprocessor is obsolete now. Yes, we can keep 2 or 3 class for microprocessor to understand that its operation. So better to start from the microcontroller, because both of them serve purpose, and nowadays the microprocessor is not used. So why we waste our time to teach microprocessor? Even different IITs also uh, accept this proposal, and they start the microcontroller from the microcontroller, so that uh, you get the flavor of modern processor. Day by day, the processor is changed. Like the computers, these are the base. All processor base is microprocessor, and from the microprocessors they are developed. So yes, for better understanding of algorithm, microprocessor serve well. Even microcontroller also serve well. So the microprocessor is a single chip semiconductor device, also which is a computer on chip, but not a complete computer. In microprocessor, the memory unit are separated. Its central processing unit contain an ALU. ALU, that is arithmetic logic unit, is a program counter, a stack pointer, and some working register, clock timing circuit, and interrupt circuit on a single chip. So the one part is CPU, and the CPU contain ALU, program counter, stack pointer, a register, few register like W and write, read, a clock timing circuit, and interrupt circuit on a single chip. So the part of the CPU is clear to you, and you know that the RAM and ROM are required for operation. The RAM is a random access memory, and this memory is actually volatile memory, and the other memory is the read only memory. Like, you consider a big hotel. In a hotel, the all rooms are indicated by a room number, and this room number is basically the address of the room. It may be vacant or it may be occupied. So the occupied means it occupied with some person. Similarly, in a microprocessor, the memories are indicated by its address. So the all memory blocks contain a specific address, and this address is fixed. And when a data may be stored or read from that memory location, it's nothing but that storing or copying this data from that register. So to complete the microcomputers, which the microprocessor is microcomputer, we have to use the ROM, RAM. The memory decoder is nothing but that it's decode its address as well as its data as per the requirement. Oscillator and a number of serial and parallel ports. Now you think about the architectures. So this part is shows a general purpose architecture. The first part is the controller. The controller is basically generate a control signal for proper synchronization. So in controller circuit there are control logic and the state register. And there are the incremental registers, program memory and program counter for which help uh, to complete the whole process. So the function of the controller is basically synchronization. So the function of the controller is basically the synchronization between the all part of the system. So data paths are basically the register file and the general ALU, and to support the system a data memory is there. So look at, we differentiate the memory unit into two categories. One is program memory and other is the data memory. So in case of the program memory, here the instructions are stored, means like the OR operation. So in case of OR operations, the computers or the processor is doing a particular task, and how a processor known that for when it encounter with OR. Remember that OR is not written OR, it depends on the machine code, and that machine code is uh, written into the programming memory. So this part is for program memory, and the other part is the data memory. Here the data, only datas are stored. Now look at this, the application specific architecture. These two near about the same. Only this part is same, control unit, logic and the state register. Control, logic and the state register, IR, PC, program memory, these are the same thing. Here the register is same. This is the general ALU, means all kind of possible operation will be done in the general arithmetic logic unit. But in case of the custom ALU, only the specific operations it capable to perform the specific operations. So why we use the custom ALU, not the general ALU? The advantage of a custom ALU that it consume less power, because the other power consumable items are not present. So this is the biggest advantage of custom ALU. In case of general purpose unit, it is designed widely so that it capable to perform all kind of tasks. So the major advantage of the custom ALU is able to operate only specific tasks. But you can program in the general ALU, you can use as you wish. Suppose you design a system using the application specific purpose, and later you want to modify that system. So in that case you have to change the whole control unit. But in case of the general purpose design process, without changing the whole system, you just modify your the software portion and it capable to perform other operations also. So this is the drawback of application specific system, means later you cannot modify if the provision is not there. So without the provision you cannot change it. Like the single purpose means it is designed for a particular task, like the LED on and off. So if you use a costly microcontroller to control your light, now this is the time of Deepavali or Diwali, and you use the varieties of light, and the cost, Chinese product cost is 80 to 90 rupees, and it gives you the varieties of light. So if they design using a general purpose microcontroller, they're not able to solve it 80 or to 90 rupees. They use this type of system. Okay, so these type of systems they use, and for a single purpose they are designing it, so that the cost reduction, but you cannot modify your system, so it is for only one task. So I hope that the differentiation is clear to you.